Hello, I'm Mr. McChesney, and today we're doing a problem figuring out the components of weight. The problem is a component of weight, a crate weighing 562 newtons, is resting on a plane inclined at 30.0 degrees above the horizontal. Find the components of the weight forces that are parallel and perpendicular to the plane. So normally, when you're dealing with problems, you've got an axis system, like in your everyday life, that usually deals with things going straight up and down and left to right, where up is positive and to the right is positive. That's the conventions. But that doesn't help us in the problem we've got here. What we've got here is, to make things simpler, is we shift our axis system so that it's perpendicular and parallel to the plane. And we call away from the plane in a perpendicular direction up, kind of up and left in this case, as positive, and straight up the slope as being positive. And I want to write out what I know to start. So I say a crate weighing, and we're going to use the symbol F little g for the force that's due to the crate's weight. A lot of textbooks you see might use the letter W, but that can cause some confusions later on when you're talking about work, which is used as a W also, or watts. The unit is also used as a W, or west. So we want to use F sub g. And we've got an angle, which we'll use the Greek letter theta, is 30.0 degrees. And so when we look at this, we want to show our information on our diagram. So I've got weight x directly downwards on our diagram. So this is my force vector, F little g, sub g. And as I'm doing this, I want to figure out a couple of things. And some stuff that usually confuses students is, how do you figure out the angle to split up this force vector, this weight vector, into perpendicular and parallel components? And I want to show you how we do that. So what we want to figure out, we want to take this weight vector and make it into something that is perpendicular and then parallel to the plane. And so what we end up with is a right triangle. And this is called resolving the vector. So I get a force of my weight, F little g, and we're going to call this the y direction. And then I have F sub g in the x direction. Now usually what confuses students is, how do we find this angle in here? And I can tell you that angle is the same as this angle over here, and I'll show you how we get that. In order to get that, what we've got here is, since weight acts directly downwards, with the horizontal it forms a right angle. And we already said that theta was equal to 30, so we know this is raised up 30 degrees, which makes this angle up here, if this is 90, so we have, in a right triangle, we've got 180 degrees. We know we've got 90 of that used up with our right triangle, with our right angle, and we subtract off 30 degrees for theta, and what we're left with is 60 degrees. So that makes this angle in here 60 degrees. So that's 60 degrees. Now if I draw a little larger version of what we're looking at, so here's our 60-degree angle, and this is the F, the weight Fg in the y direction, or perpendicular direction. So that means it's perpendicular right here. We've got 60 here. We've got two lines that bisect each other, so that makes this angle also 60 degrees. So we got 60 degrees here, 90 degrees here. That means this has to be 30 degrees. So whenever you do these problems, the angle that the hill is inclined at is exactly the same as the angle between your weight, F sub g, and the perpendicular component of that weight, F sub g sub y. Alright, so you can always find that angle. That angle is always going to be the same. So this one is 30 degrees. Alright, so now let's figure out how we find these components of the weight. And in your math class, you may have heard the little term SOHCAHTOA. And that's a little mnemonic device to help you remember how to do some simple trigonometric things. We've got sine equals opposite side over hypotenuse, cosine equals adjacent side over hypotenuse, tangent equals opposite side over adjacent. So I want to find out my perpendicular force, my FGY. And that is, for this angle, it's touching the angle. That makes it the adjacent side. And I know my hypotenuse, my weight, so I have my adjacent side and I have my hypotenuse, so I'm going to use cosine. So as I write out the formula, it's going to be cosine of my angle. So cosine of theta equals my adjacent side, which is F sub g sub y, divided by my hypotenuse, which is my weight, F sub g. Now I know what F sub g is, and I know what my angle is, so I want to isolate this right here, the perpendicular part. So I'm going to multiply both sides of the equation by F sub g, my weight. If I do that, I cancel out the weight on this side, and my equation becomes the perpendicular force of the weight, or perpendicular component of the weight, is equal to the weight times cosine of the angle, theta. Right. So I know a couple of things. I know that my weight is 562 newtons. I know that my angle is 30 degrees. I know it's actually 30.0 degrees, and I'm putting it there because we have some significant figures we'll need in a little bit. And I also know that my weight goes downwards. Since it goes downwards, that's the negative direction. So you want to keep track of that. Otherwise, you're going to get an answer that's positive, meaning it's going up and the Earth is repelling you, which is not what we want. All right. So as I plug these numbers into my calculator, I'm going to get an answer that is 486.706, and the unit's going to be newtons. Now, here's a problem you may run into. You may not get this answer. If you don't get this answer, that could mean your calculator's in radians, not degrees. You may end up with a really tiny number, or you may end up with a positive number when it should be negative. So if you get a number that's not this, then go back and check to make sure that you're in the correct mode for your graphing calculator or your scientific calculator. And as I'm looking at this, I've got 6 digits in my answer, but I only used 3 digits in my first number and 3 significant figures in my second number. So since I have 3 and 3, my final answer has to have 3. So that means I've got to round off at this 486, at the 6, and that means I got to look at the 7, the one behind it, and since that's greater than 5, that means I should round up. So my final answer for this part of the problem is going to be negative 487 newtons. So there's my final answer for the perpendicular component of the weight. Okay, now for the next part of the problem, we're going to look at the parallel component of the weight. So if we look at this, we know our hypotenuse, we know our angle, and we're dealing with the opposite side. So if you go back to that new mnemonic device, we're going to use the SOHCAHTOA part of SOHCAHTOA. Sine is opposite over hypotenuse. So we've got sine of our angle, theta, equals the opposite side, f sub g sub x, divided by our hypotenuse, which in this case is our weight, f sub g. And again, we're looking for this part on top, so we want to get rid of the part on bottom of the fraction. So we got to multiply both sides of the equation by our weight, f sub g. If I do that on this side, they cancel out, and that's going to leave us with our parallel component of our weight, f sub gx, equals our weight, f sub g, times the sine of the angle, theta. So we know that our weight is 562 newtons times sine of the angle, which was 30 degrees, 30.0 degrees. And don't forget, the weight acts downwards, which is in the negative direction. So you have to include that in your part of your problem, in your numbers. So when I type all those numbers in, I get the parallel component of my weight is negative 281 newtons. And that's rounded off for our significant figures. And the last thing we want to look at here is when writing a force diagram, which is what we've got here with this crate, is we don't want these vectors just kind of hanging out here loose by themselves. We like to write them right on the center of the box. So what I'm going to do is I'm going to move it, which I can do if I move it parallel. So I'm going to fix a few things there as I erased a little bit too much. So I like everything to go from the center there. This is just the conventional way, the way most people do it. Alright, so once I've resolved my vector, a way to keep track of things is then to cross out the weight vector, because I'm no longer using that. I'm using the component parts. And what we've got there is how to resolve your vector into component parts so that you can later solve different problems. So we get our parallel part is f sub g sub x is negative 281 newtons, and we had our perpendicular part, f sub g sub y, was equal to negative 487 newtons. Now if we look at our diagram, they're both going opposite the direction of the positive direction, so they both should be negative. And that's how you solve for the components of weight.